Math 1, sequences 1.5. So we're taking a look at the growth, or also known as the rate of change. Okay? So the same sequence is shown in both a table and a graph. We're going to indicate on the table where you see the rate of change of the sequence, then draw on the graph where you see that same rate of change. Okay? So if I'm looking at 1, starting here at 2, as we go down, 2, 5, 8, we're adding 3 each time, right? So we see that growth, that rate of change, as we add 3. Well, where do we see it on the graph? Well, we see it that from one point to the next, we're going up 3 and over 1, but we're going up 3 each time. Okay? That vertical. Now, it would also be interesting to notice that on the horizontal, because we're going over 1 each time, we can also see that on the horizontal. Okay, number 2, we've got 13, 11, 9, 7, 5. Hopefully we can see we're subtracting 2 each time. Where do we see it? We're going down 2 each time. Okay. Number 3, 16, 11, 6, 1, negative 4. We're subtracting 5. We can see it here on the f of n values. We can see it as these points each go down by 5. Number 4, we have 0, 4, 8, 12, 16. We're adding 4 each time. Where do we see that? We're adding 4 each time these dots go up. Alright, so recursive and explicit equations. We're going to practice writing recursive and explicit functions of geometric sequences. Okay, so remember, arithmetic, that is when you add or subtract the same number over and over. Geometric. So geometric, okay, we multiply or divide. Okay, so, but the recursive is basically the same format. A sub n equals a sub n minus 1, whether it's arithmetic or geometric. If it's arithmetic, we add or subtract. If it's geometric, we multiply or divide. Okay, and then a sub 0 equals our start number. So we go 2, 4, 8, 16. We might want to say, sorry, where was I? So 2, 4, 8, 6, you may think it's plus 2, plus 4, plus 8, but remember, we have to have the same number added, so it can't be arithmetic. So if it's not arithmetic, we're just dealing with arithmetic and geometric. So is it geometric? Well, are we timesing by 2 each time? Yeah. So our growth is timesing by 2. So what's our start number? Well, if we go back 1, okay, so we do the opposite. 2 divided by 2 would give us 1. So our start number is 1. So recursive, a sub n equals a sub n minus 1 times 2. And a sub 0 equals 1. For our explicit, we go a sub n equals our start number 1. And then what are we doing? We're timesing, so times by 2. Now we're going to have repeated multiplication. We got to remember, repeated addition or subtraction is multiplication, right? That would be 3 times 2. That would be 3 times negative 2. Repeated multiplication is what we call exponents. So 3 times 3 times 3 is 3 cubed. Okay, so that n jumps up there on the 2. So 1 times 2 to the n. Okay, now if we were to graph this, okay, so there's 16. So I'll do it in purple. So that's 0 would be 1. Okay, at 1 we go up to 2. At 4 wait, no, at 3 we go up to 4. At 4 we go up to 8. And then at 5 we'd go up to, or no, at 4. Wow, I'm totally off, huh? Well, we found the 0 one to be 1, so 1, 2, 3, 4. Because I counted 0 as 1, didn't I? So at 4 we go clear up to 16. Okay, so if we were to connect it, looks something like that. So this would be our n and a sub n. Alright. Okay, now we're given a table. The time, days, and number of cells. So we go 3, 6, 12, 24. Again, we should see that we're timesing by 2 each time. Now, if I'm going backwards to 0, 3 divided by 2 would be 1.5. So I go a sub n equals a sub n minus 1 times 2. A sub 0 equals 1.5. So now notice something that's I think interesting to note. This first part of these two different sequences is the same, but their numbers are completely different. That's why the starting number is so important in distinguishing between the different sequences. So explicit, a sub n equals our starting number, 1.5, times 2, and let me write that a little better. Okay. So a sub n equals equals our starting number. Let's see if we can get this right. 1.5 times 2 to the n. I am just off my game right now, aren't I? Okay, then if we graph it, so 1, we're at 3. 2, we're at 6. 3, we're at 12. And then 4, we'd be clear up at 24, so we'd basically have to double that same. So it'd be like clear up here-ish. And then at 0, we were at 1.5, so right about there. So it looks something like that. Alright. Ooh, now we got some story problems. So it says, Claire has 300 in an account. She decides she's going to take out half of what's left in there at the end of each month. It's always a good idea to write a table here. So she has her money. Okay. And then each month, right? So before she starts taking money out, she has 300. There's our starting number. A sub 0 would equal 300. A sub n would equal 300. Then she's taking out half. Okay, so the first month we take half out, we have 150. Second month we take out half, we have 75. Third month we take out half, we have 32.5. Okay, and so on. So what are we doing here? Okay, now we want to say divide by 2, right? And for our recursive we can. A sub n equals a sub n minus 1 divided by 2. Okay, but we actually, when we're dealing with geometric sequences, we don't like to write divide, because I can't really do divide 2 and make a power. Okay, so what's the same as dividing by 2, but using multiplication? It's 1/2. So instead of dividing by 2, we need to get in the habit of timesing by 1/2. Same thing. Times by 1/2 raised to the n power for the explicit. Okay, so then we start out graphing. There's 300. Okay, after the first month, we go halfway. After the second month, we're halfway. Third month, halfway, and so on. So we just keep kind of curving down like that some way. Alright? Okay, it says Tanya creates a chain letter and sends it to 4 friends. Alright. So she started out and sent it to 4 friends. Each day, each friend then is instructed to send it to 4 other friends. So now we're sending it to 4 more friends. So each friend sends to 4 friends, which would be 16, which we're timesing by 4. Timesing by 4 and so on. Okay? So our starting number is 4, and our growth is 4. So, recursive a sub n equals 4, or a sub n equals a sub n minus 1 times 4, and a sub 0 equals 4. So the explicit a sub n equals starting number of 4, or times them by 4. We keep times it by 4, so we put to the n. Okay, now number 9, I don't think it printed off very well, but this should be day 2 and day 1. Okay, so we go from 6 to 12 to 24. So at day 0, we would have started with probably 3. So I go a sub 0 equals 3, then a sub n equals a sub n minus 1, 3, 6, 12, or times them by 2. Explicit a sub n equals our starting number 3 times 2, and we keep times them by 2. So to the n, that repeated multiplication. Alright, I didn't graph either of these two, did I? So we have 1, 2, 3, 4. Actually, I'm going to count by 4s. 4, 8, 12, 16. So 1, we're up to 16. 0, 4. To get to 64, we're going to have to go quite a bit more, aren't we? So basically, this graph is just going to keep climbing up pretty quick. Okay, and this one, we start at 3, so I'm going to count by 3s. 3, 6, 9, 12. So day 0, we're at 3. Day 1, 6. Day 2, 12. Day 3, 24. So 15, 18, 21, 24. And then so on. Alright, now we have arithmetic. So now we're switching to the add and subtract. Okay. So 2, 4, 6, 8. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So we're adding 2 each time. So if we go backwards to our first term, it's 0. So 0, 0, 1, 2, 2, 4, 3, 6, and 4, 8. Okay. Recursive would be a sub n equals a sub n minus 1 plus 2. And a sub 0 would equal 0. Explicit, a sub n equals my start number 0 plus 2. And because it's repeated addition, we go 2 times n. Okay, now hopefully you kind of pay attention to, we've got some similarities here on these numbers and these problems that we're going to be doing. Okay, so number 11, and we've got 1, 3, 2, 6, 3, 9, and 4, 12. Okay, if we can tell, we're adding by 3 each time. So going backward, we'd have 0, 0. So look something like that. So starting 0, growth 3, a sub n equals a sub n minus 1 plus 3, a sub 0 equals 0. Explicit, a sub n equals 0 plus 3 times n. Alright, now 12 says Claire has 300 in an account. She decides she's going to take out 25 each month. So when she starts out, 300. So we start out at 300 here. After the first month, she subtracts 25. So that would be 275. So let's make this 150. That would be 75. So, we started out at 300, didn't we? Okay, so she's got, after 1 month, 275. After 2 months, 250. After 3 months, 225. probably be a little higher, huh? And so on. And it looks something like that. Starting number 300, a sub 0 equals 300. Okay. A sub n for explicit equals 300. She's subtracting 25 each time. So we get minus 25n for the explicit, and a sub n equals a sub n minus 1 minus 25. Okay, 13. Each day Tanya decides to do something nice for two strangers. What is the relationship between the number of people helped and days? So days, people helped. So she started out, she didn't help anybody. After day 1, she helped two strangers. Day 2, she helped 2 more, so 4. Day 3, 6. Day 4, 8, and so on. So 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, and so on. So, recursive, our start number is 0, and our growth, a sub n equals a sub n minus 1, and we're adding 2 each day. So, explicit a sub n equals our start number plus our growth times n. Alright, last problem. We start out on day 1 with 6, then we go 12, then we go 18. So we're adding 6 each time. So if we go back to day 0, there would be 0 dots. So a sub n equals a sub n minus 1 plus 6. A sub 0 equals 0. Explicit, a sub n equals starting number of 0 plus our growth times n. Start out with 0, 0, 1, 6, 2, 12, and 3, 18. Our graph would look like that. So, pretty interesting to compare the differences, right? If we look at number 6 with number 10, if we look at, or number 5 with 10, number 6 with 11, number 7 with 12, 8 with 13, and 14 with 9. Pretty interesting to see the similarities and the differences on this. But there we go, guys.